You guys, we're on page 8. We're talking independent, quantities. We're talking independent and dependent quantities and what those represent. Of course, variables is going to come out in the conversation. And when we talk about the origin, it's the coordinate 0, 0. And it has a meaning when we're able to ascribe independent. What is it relying on? How does it impact the dependent? So stick around and let's go ahead and answer the independent-dependent quantity for our scenario. Choose an appropriate graph from our options that are left, and then write the scale. Oh, and also, by the way, the origin. We need to know the origin and what it represents, because sometimes the origin is useful, other times it's just a starting point. Baton twirling. Jill is a drum major for the Altadena High School Marching Band. And for the finale of the halftime performance, Jill tosses her baton in the air so that it reaches a maximum height of 22 feet. This gives her 2 seconds to twirl around twice and catch the baton when it comes back down. It's this graph. It's this graph because she's only so tall and she tosses the baton 22 feet in the air, and then by the time it gets back down to her, it's taken 2 seconds. So if you take that graph and you split it in half, right down the middle, that's 1 second of time. And then, I don't know, maybe I'm going to count by twos. 2, 4, 6, 8, 10, 12, 14, not tall enough. 3, 6, 9, 12, 15, 18, 20. It's going by threes. So 3, 6. I guessed and checked, and that's what happened. And I also used the information like the 22 feet and the 2 seconds to know how to put scale on this graph. But what's the independent quantity in here? Time. I see the time second. I see time right here. Time, 2 seconds. So seconds is going to be the independent quantity, specifically time measured in seconds. We also should get that from the graph, right? Independent quantities go on the x-axis. And I probably want to put that on this post as well, that we want independent quantities to go on the x-axis. We want dependent quantities to go on the y-axis. So in this case, what's the dependent quantity? She's tossing her baton. And, well, when you toss a baton, you get a height. So that has to be height is the dependent quantity. How much time, like at what time, that's what it is. At what time, huzzah, did Jill toss the baton in the air, spin around, do a cool twirl, and then catch it? Because at a specific moment, we can say the baton is, this high up in the air. So dependent height, measured in feet. Those 2 pieces of information go on the graph. So I'm going to put time in seconds. I decided to spell out seconds here for some reason. And then I'm going to put height of the baton when Jill twirled it in feet. Okay, I'm going to glue that down here in a minute here. One more thing, though, let's talk about the origin. The origin is 0, 0, because that's the location where both the dependent and the independent lines meet. 0, 0. So the origin, 0, 0, represents 0 seconds with 0 height on the baton. Not really like happening in the situation, but definitely what we're trying to address. Now, last scenario for page 8, and it is this graph. The number of guests at a ski resort on any given day is related to the day's temperature. When the high temperature is minus 20 degrees Fahrenheit or below, no one comes to the resort. As the temperature increases, so does the number of guests. You guys, this sentence right here, as the temperature increases, so does the number of guests. That's the sentence that tells us what our independent and dependent quantities are. Do you want to know how many guests are going to be at the resort? Well, what temperature is it? How many guests are at the resort? Then it must be so many degrees. It doesn't quite work. It sounds weird. It sounds backwards to say it this way. Hey, we got 100 guests at the resort. That must mean it's 20 degrees outside. After we already knew they were there. Hey, it's going to be 20 degrees outside. How many guests are we going to have? 100. That is more direct and natural feeling than the first way I said it. That means temperature in this scenario, because temperature increasing is measured, temperature is independent and the number of guests is dependent. Write it down. Temperature. I also notice that's F. So temperature measured in degrees Fahrenheit. And the dependent quantity, the number of guests. And that's just a count. That's just how many guests there are. So origin, since I'm right here and I'll write it down anyway, origin as in 0, 0 means for 0 degrees Fahrenheit, there's 0 guests. Which is not true because we have a different scenario in the graph that says over here at minus 20, we have 0 guests. That also tells us then when the temperature is 10 degrees Fahrenheit or higher. Oh, okay, 10, right here, 10 degrees. The ski resort has met full capacity with 400 guests. So we have temperature on T-U-R-E, there we go, temperature on the bottom, and then we have number of guests on the dependent. There you have it. So for some scaling, it looks like every one of these boxes goes by 5. And then for this one, I'm going to count by 20s. So 20, 40, 60, 80, 100, 20, 40, 60. No. How many actually is that? That's 1, 2, 3, 4, 5, 6, 7, 8. 400 divided by 8 is 50. We're going by 50s on the y-axis. 50, 100, 50, 200, 50, 350, 400. So our scale really does matter. And this technique down here, 400 divided by 8 boxes, it's a good pro tip. Use it. Thank you for watching, commenting, liking, and subscribing. I will go ahead and finish gluing these graphs down so that I can have them for record for the future. But thank you for watching. Page 9 is next. I'll see you there. Stick around, and I'll see you in the next episode. Independent quantities, dependent quantities depend on independent quantities. Yeah.